All right, let's discuss our test for this Friday as usual. Chapter 2 test review. Question 1, graph and line. So we're going to start at 2, and we're going to go down 7 over 2, just as we've always done with graphing lines. Question 2 starts at -2 and goes up 2 over 1. There we go. Question 3. Slope-intercept form of the equation given that's parallel. Slope-intercept form through the point with a slope of -2/3. Well, I'm looking at these equations. This is my slope. And this is the only one with a slope that matches. So that's a pretty easy question. D. I don't even have to figure out the whole thing. Now if I happen to set this up correctly where I have actually a question where you have to actually do some work for, you would have to set it up y minus the y value equals m times the quantity x minus the x value. And then you'd have to find out what the y-intercept would be. So if I had two of these with the same slope, this is what you would do. And you would distribute the -2/3 into the x plus 3. It would be -2/3 x plus 6/3, or -6/3, which is -2. Adding 3 over to -2 makes +1. So that's what you would do if you needed to actually set this up. If I had two of these with the same slope, with the -2/3 slope. All right, same thing on this one. Write the point slope form of the equation on the line through the given point with the given slope. So -4/5. This is the only one with -4/5 slope. It's got to be 8. But if I happen to set it up correctly, where you have two options with the same slope, -4/5, you would say y plus 3 is equal to -4/5 times the quantity x minus 2. There you go. All right. Standard form for equation of a line. So this one, there's a lot to consider here. You need to figure out what perpendicular means, which means flip the slope. So instead of 3/5, it's going to be 5/3. It's -5/3. So the slope perpendicular upside down t, is -5/3. And then you need to do the point slope form and convert it into standard form. Now you could use this as well to get your coefficients, 5 and 3, coefficient of x, coefficient of y. Or also, there's another option here where you can use this equation as well. But I think this is the quickest one. So I'll start off in point slope form because that's what I was given. I was given a point and I was given a slope perpendicular actually. So I'll have y plus 5 equals -5/3 times the quantity x minus 3. I'll distribute the 5/3 through in parentheses, so y plus 5 equals -5/3 x. The 3's there will cancel, plus 5. It's looking like these 5's are going to cancel here. They're opposite signs. So I can just cancel them out. So I have y plus 5 equals -5/3 x. And these 5's will cancel. And then I can move the 5/3 over to the other side. Positive 5/3 x plus y equals nothing. Then I can times everything by 3 to get the appropriate answer, which is letter B. There might be an easier way to go about this one, where you could perhaps match it easier. But this is the way that came to my head when I was doing the question. Where you put it in point slope form, distribute, combine the constants, and times by the denominator here. Anyways, I'll think about that one. Maybe I'll show you something different in class. Question 6. Find the zeros. So this basically means factor. If it factors. If it doesn't factor, then you have to do the quadratic formula. This one does happen to factor because looking at the options, they're all, fractional or integer. So I know it factors from the options right here. So I'll look at this and I'll say, well, how do I get the 7 from the 5 and the 2? Well, the 5 has to be 5v times v. And then that 2 has to be a 2 and a 1. So is it here or is it here, the 2? Well, it's both plus because it's plus 7. Well, if I put it here, that's going to be 10v. I don't want 10v. I want 7. Put it here, it's going to be 5v plus 2v. Yeah, there it is. That's what I want. So this one solves to be negative 1. This one solves to be negative 2/5. Taking 2 away, divided by 5. So again, I did that factoring by guess and check. But, you can do it the X method, the box method. Or you can do quadratic formula with these as well. Here, everything's on the m and the 3 are on the wrong side. I'll move them over, m squared plus 4m plus 3, not minus. And I'll look at that and I'll say, well, that one factors as well. It's equal to 0. So that's m plus 3 and m plus 1. So m's going to equal negative 3 and also negative 1. Negative 3 and negative 1 will be my two answers there. So again, what I'm doing there, just solving for the variable. Setting it equal to 0, solving for the variable. All right, identify the domain and range. Describe the transformation from the parent graph. So the domain here, x has to be greater than or equal to negative 4. So you can write it like that, or you can write it like we did in class, negative 4 comma infinity. I'll write it like we did in class. And it includes negative 4, so I'll put a bracket around instead of a parenthesis. The range here is going to start off at 0, because the smallest thing you're going to get out of square root is a 0, and it's 0 plus 1. So the range starts at 1 comma infinity. I said 0, didn't I? 1. Because the smallest you get out of a root is 0 when you put in 0. Negative 4 plus 4, 0. Which would yield a 1 from there. The transformations from the parent graph are going to be left 4, up 1. Left 4. That's horrible writing there. Left 4, up 1 from the parent graph. Right, another square root. Again, the domain here, you can't have negative roots, so it's going to start off at negative 5, because 0 is the smallest root you can do. The range here is going to start off at 0 this time, because the smallest thing that comes out of root is nothing. So this is moved left 5. And then you can say it two different ways. You could say it shrunk by a half or compressed by a half. So shrunk by a half or compressed by a half would be the proper ways to say that. Okay, next question. Identify the center and radius. Center 1, negative 3. 1, 1, 2, 3. Radius, square root of 9, which is 3. And then sketch a graph. So 1, 2, 3 on each side of the center. 3 on each side, making the circle. There you go. All right, bottom of the page here. Determine the domain and range. Find each real 0. Find the relative minimum maximum. State where the graph is increasing or decreasing. So for you guys in the other classes, you will have to graph these yourselves. You'll graph them on the calculator, of course. For my class, I will graph it for you. So what we're looking for here, each real 0, let's start off with the zeros. The zeros are going to be where it crosses the x-axis. So this particular graph comes down and it crosses the axis at right around negative 5. That's its first 0. And it has a bottom of its trough at right around negative 4, negative 5, negative 4, negative 5. Again, for my class, it'll be drawn for you. That's called the minimum. So this is a min, or relative minimum. Negative 4, negative 5. And again, that might not be exactly negative 4, negative 5. I'm not using the calculator here to get the actual values. I'm just approximating it with a graph that I have pre-done. Then it comes back up through about negative 2.5. It comes through the axis, so that's another real 0. X equals negative 2.5 or 2.5 about. Then it's at the top at about here at negative 1.5 and 4.5. That's the relative maximum. Maximum, negative 1.5, comma 4.5. Again, for my class, you're just approximating these. And it comes back down through the graph at about negative 1/2. So that's another 0. The y-intercept does not count. We don't need the y-intercept here of negative 2. It doesn't really matter. It's not part of our answer. All right, so that is our zeros, min, max. So we did zeros, min, and max. We have to do domain and range and increasing, decreasing. So the domain and range are both full because it points up and down for the range. So the arrows point both up and down. And then for the domain, they both point, one points left, one points right. So you have a pointing all the directions, up, down, left, and right with the arrows. All right, increasing, it's increasing on this interval here and decreasing on the rest of it. So we're going to have increasing interval on negative infinity all the way to my minimum. Negative infinity, comma, negative 4. Sorry, that's decreasing. Decreasing. The increasing interval is negative 4 to the max there, negative 1.5. And then it has another decreasing interval from negative 1.5 to positive infinity. Negative 1.5 to positive infinity. Everything bigger than 1.5 on the x. Sorry. And again, when you're doing increasing, decreasing, you're looking for as x gets larger, what happens to y. So as x gets larger here from the left over, it gets y gets smaller, gets more negative. Starts out positive and gets negative. And as x gets larger here, y starts off negative and gets to be positive. It gets larger. Then from here up, or from here to the right, I should say, like 1.5 to the right, as x gets larger, y gets smaller, it gets more negative. It starts off positive and it comes down negative. Decreasing intervals, in other words. All right, one more page. Evaluate each function. I'm going to put in n minus 1 for n. So f of n minus 1, we're going to have 2 times the quantity n minus 1 plus 3. So that's 2n minus 2 plus 3. Minus 2 plus 3 is plus 1. Letter D. G of negative 8, we're going to put in negative 8 for x. Negative 8 plus 1, negative 7. P of 2, we're going to put in 2 for n. Negative 4 times the quantity 2 plus 5. Well, that's negative 8 plus 5, which is negative 3. The spacing here has nothing to do with the length of the problem. It has to do with this problem here being x squared. Got your graph of the function. Describe the transformation from the parent function. So this is our transformation question. The parent function is x squared, which is, again, starts off at 0, 0, then 1, 1, then 2, 4, negative 2, 4. This one's moved right 2, up 3. Right 2, up 3. So you can draw both functions if you want, but you just have to really draw the finished graph, the ending function. So it's right 2 and up 3 from the parent function. So its vertex is here. And then its next 2 points are here and here. So those 2 points again are right 1 up 1. And you can also think of it as if I put in 3 here, I get 1 squared, and 1 squared plus 3 is 4. If I put in 1, I get negative 1 squared. If quantity of negative 1 squared. Quantity negative 1 squared is 1 plus 3 is 4. And the other 2 points are going to be at 7s. And again, if you want to plot the original graph, you can plot the original graph and then just go right to up 3 for all the points. So like the 2, 4, right to up 3. Well, if you get the graph, and then the negative 2, 4, right to up 3 to get the graph of the new parabola or the transformed parabola. It has a horizontal and a vertical shift, in other words. All right, use the algebra test to determine if it's even, odd, or neither. So we're looking to see if f of negative x, what happens with f of negative x. So if I put in negative x here, negative x squared plus 6, well, that stays as x squared plus 6, doesn't change it at all. So if it doesn't change it at all, we call that even. Or it doesn't change the function at all. And you put in negative x. That's like a y equals x squared function, like this one right here. The original one, not the transformed one on number 15. This one, when I put in negative x, it does change the 2 to be opposite. I should say negative t. This is g of x, this is g of t. I should actually use the same variable. Let's just quickly change that to an x cubed instead of a t cubed. So 2 times negative x to the third minus 8. That's going to make that a negative 2x to the third. The issue here is the minus 8. The minus 8 didn't change signs. If it had changed signs, if it had been a negative 8x, minus 8x, this would be an odd function. But because that minus 8 stayed as a minus, this is neither even nor odd. So for odd functions, it has to be the opposite signs for all the terms. And you put in negative x. In other words, the exponents all have to be odd. 3, 1, 5, 7, 9. For even, they all have to be even exponents. 2, 4, 6, 8, and in this case, constants, which are x to the zeros. Zero is an even number. All right. 18 through 20. Cadence cell phone cost for 4 minutes is 36 cents. And 10-minute call is 43 cents. What is his rate of change? So this is just asking you for the slope. So we increased by 6 minutes, and our cost increased by, and you can use a calculator to figure this out if you want to, and probably should. So I can decide whether to put the decimal, the money in the top, and the minutes in the bottom, or the minutes in the top and the money in the bottom. Well, usually it's money per minute that you pay, not minutes per money. So we're going to put the money in the top. So 63 cents minus 36 cents divided by 10 minus 4. And again, I can use a calculator here. I don't have to do this part by hand. 0.63 minus 0.36 is 0.27. So it's 27 cents. And then 10 minus 4 is, of course, 6. So dividing this by 6. And that's about 4.5 cents. 0.045. We're not going to round this number, because if we round this number, we're going to end up making some mistakes somewhere. So what is this? 4.5 cents per minute. Yeah? Because it's price per minute. So now we're going to go to the next function. Find a linear function in slope-intercept form that represents the total cost of the call duration in minutes. So we can say C, cost, is equal to 0.045 per minute, plus there should be a y-intercept here. I have not found the y-intercept yet. So to find the y-intercept, I'm going to have to do a point-slope form. I'm going to have to match this with a point-slope form. I'm going to have to find the y value. Either that or I do a point-slope equation and leave it in point-slope. So to do the point-slope equation here, I'm going to have to do the x and the y. So I have to have the money as the y and the price as the the minutes as the x. So my point-slope form, or my point-slope equation, I'm going to say c minus 4 is equal to 0.045 times m minus, and this should have been the y value. The 4 should be here. 0.36 should be here. All right, I'll distribute the 45 to the minus 4. 0.45 times minus 4 is 0.818. So C minus 0.36 is equal to 0.045 M minus 18. I'm going to add the 18 to the, I'm going to add the 36, the 0.36 to the negative 18, and I'm going to get 0.18. I did 0.3 there on the calculator. Negative 0.18. 18 plus 0.36, 18. So my y-intercept is 18 cents, in other words. I needed to find a y-intercept there. To write a y-intercept equation. I had a slope of 4.5 cents per minute, but I needed an 18 cents. I needed a y-intercept there. Set that up. All right, so for a 2-hour and 40-minute call, we're going to convert that all into minutes and put it in for here. So 2 hour, 40 minutes, this is 120 minutes plus 40 minutes. It's 160 minutes. So that's going to be the value of M. So I'll do 0.045 times 120 plus, or excuse me, times 160. 160 minus, not 120, plus 18 cents. $7.38. All right, so if you happen to mix up this equation, at least put your minutes in to the equation that you used here, that you got, and I'll give you credit for number 20 if you happen to mess up this equation. At least give it a try. Good luck.